Alright, so for this presentation, we're going to be talking a little bit about the losavastin. So just a little bit about this. What exactly is this? So it's a drug. It belongs to a class of the statins. It helps lower cholesterol in the body. It works by inhibiting an enzyme called, it's the HMG-CoA reductase. So it's an early step of cholesterol biosynthesis. This is involved in removing the lactone group and converts losavastin to a hydroxy acid form, getting the losavastin acid. So how is cholesterol synthesized? So 10% of cholesterol is synthesized in the liver, 15% is in the intestine. It's carried out in the cytoplasm with acetylcholine, which is a product of oxidation in the mitochondria. So there are 5 steps in the process of cholesterol. So acetylcholine is converted to 3-hydroxy-3-methylglutaryl CoA. So in other words, it's the HMG-CoA. And then that is converted to the mevalonate, and that is to convert to the isoprene-based molecule, which is IPP, and that is the loss of the carbon dioxide, and that is converted to the squalene. And then finally, squalene is converted to cholesterol. So it just shows kind of each step of how it goes. So it starts with the acetylcholine, goes to the acetylcholine, down to the hydroxy group, which is the HMG, and then that is finally going to the mevalonate, and that is for step 1. Step 2, it goes from that to the phosphomevalate, putting that phosphate group in there. Then just adding more phosphate with ATP. And then it is going to 3-phosphate-3, the pyrophosphate mevalate. So we're just keep adding that phosphate group in there. Then after that, it's removing carbon dioxide and a phosphate group. So then that final product for stage 2 is going to be getting us the dimethyl pyrophosphate. There is that stage 3, so we're going from the last product we had. Then we are getting the general pyrophosphate, which is 2 isoprenes. And then so that final product is going to be that farnesyl phosphate. So this kind of shows the conversion for squalene to cholesterol. So we start with that squalene molecule, putting oxygen into it, making that the epoxy group, which is in that area right over here, having that H ion kind of out to the side. Then we get lanosterol. There's 20 steps in that, and that finally gives us the cholesterol. With the acetylcholine cholesterol, it can give us esters, which is principal transport form in the blood. And so how does losavastin inhibit high cholesterol? It reduces the amount of cholesterol in the body. This works by blocking an enzyme that is needed to make the body, or needed by the body to make cholesterol. And that is the presentation I have today.